Jackie, most of your grade comes from quizzes and tests. So the practice quiz, you have to be smart. You could copy it, you could use like software to get all the right answers. None of that would really help you do well here. Because having all the right answers on this practice quiz that we're going to give you for that Thursday, having all the right answers won't help you. Knowing how to get the right answers on your own will help you. Make sense, Ernesto? Okay. All right. So, yeah. You gotta use it to understand. So, what I'll do on next Tuesday, I'll give you the assignment that's here. Make sense, Jackie?
Makes sense.
All right, Jackie. Jackie, do you have homework questions?
No.
No? Why? Because you didn't do it, huh? Again, Jackie.
Well, it's like when I left my papa.
I see. Ernesto's got questions, right? What's your question, Ernesto? What page is it? Remind me. Chapter 1.3, right?
Page 43.
43. All right, let's take a look at that. Oh, I found it right here. 67. Oh, yeah. 5/4 divided by 3/8. Actually, that ties into what we're going to learn first today. So let's do that one. Homework review number 67. 5/4. 5/4 divided by 3/8. So in your notes, I guess what you could do is you could write, hold on, let me fix this. Is that clear? Or is it?
Clear.
Okay. So in your notes, I guess this would be homework review, right? Whoa. All right. Now, this is division, right? And the way you divide is you multiply by the reciprocal, right? Of the second one. You're dividing by 3/8. That's what you're dividing by. So this is really going to be 5/4 times 8/3. Yeah, Marlene? Yeah, Marlene?
Yes.
So we're going to tie this into what we're going to learn to do today. And that is, we are going to learn how to reduce. Yeah. You look pretty excited today.
Yeah, something different.
Long day?
Long day.
Yeah. Reduce just means make small, right? Make smaller? So what we're going to do is we're actually going to make this smaller. If you just multiplied without reducing, you would get 40/12. Is that right? Is that right? Okay, that's correct, but it's not reduced. And after right now, you have to reduce. So Eileen, if you had this as your answer, you would be good to go. So Ernesto, if that's what you got, you're all right.
Right.
Is that what you got?
Yeah.
Okay. Did you also reduce it? So you even got better, huh? So check this out. Let me show you how to do it, and then I'm going to explain why it works. Because how we do it on paper is actually kind of a shortcut. So here's what we do. On paper, we say, oh, look, 4 and 8. There's something on the top and something on the bottom that have a common multiple. So we can reduce this. Hi, guys. So you see 4 goes into 4 one time and 4 goes into 8 two times. And so what we really end up having is 5/1 times 2/3, and that's 10/3. Right. If you had 40/12, do you see that there's a greatest common factor that 40 and 12 has? 4, because that's 4 times 10, and this is 4 times 3. Do you see 40 has a factor of 4, and 12 has a factor of 4? So what this really is this is really 4 times 10 divided by 4 times 3. And Jacobo, I'm not very good at math, but I think 4 divided by 4 is 1.
Mm-hmm.
Yeah? You agree? Okay, good. I'm more comfortable now. So that's 1. So that's just 10/3. Do you see? Same thing. What do you think, Jackie? Kind of confusing? Yeah, why is that? What part's weird for you?
Why do I still get confused on the GCF? Not confused, but 16 times.
Yes. That's actually one of the problems. Like, when you see, like, a math teacher doing the math, they've done it forever, they're experts at it, it doesn't take any time at all. I don't even have to think about it. In fact, a lot of the time I make mistakes, it's because I didn't actually think about it. I've just done it so much, I kind of have an idea of what's close. Yeah. Huh. Yeah. Just like your mom probably knows when you're lying, even without talking to you very much. Even if she doesn't say anything, she's got you fooled.
No.
If you think your mom doesn't know when you're lying, you're full of it, right? Your mom knows when you're lying. And if you think she's dumb, then you are totally fooled.
She doesn't.
No? Okay.
She still lies.
Oh, I see. I see. All right. So anyway, so Yolanda, if you forgot to reduce before you'd multiplied, you end up with a big number like this. Oh, sorry, like this, right? And then you have to reduce afterwards. You have to look for the greatest common factor. But it's easier before you multiply to look and see if anything has a common factor. So you're looking for like a factor that's common on the top with the bottom. So like let me show you this. This you can't reduce. Different problem, not the same, right? Here's what I did. These have common factors, one in the numerator, one in the denominator, and that's why you can reduce. But this, there's common factor, but it's both in the denominator, and you can't reduce it. So this one would be 32 and 15, and that's reduced. There's nothing in common. But this one, like we showed you right here, 4 and 8 have a common factor of 4. So what you're really doing is you're dividing that number by 4 and that number by 4. And that's how you get 10 over 3. Yeah, Ernesto? Does that make sense, Ernesto? Or not really?
Yeah.
Yeah. I have a question for Marlene. Hi, Marlene. Marlene, I'm really tired. I'm trying to wake up. Yeah. I'm trying to get my mojo to bring some excitement. So before I ask you my question, I have a story for you, or kind of a weird thing. Have you guys ever been laying down with your legs crossed, and then after a while you don't know which leg's on top unless you look or move a leg? You had that happen, Jackie? Yeah. That's just because the brain gets confused by the nerve signals, right? Well, it turns out your middle two fingers, these two fingers right here, they share nerves, and they also share tendons. They don't move very strong independently. You can move them separate, but it's hard, and they get weak, and if you do it for very long, they get very tired. Together, they're very strong. You can move those two fingers very, very strong together. You can grab things very strong, but with just one, it's weak. The nerves are the same. Okay? So, on my ring finger, on Sunday, I had a giant splinter that went all the way down to the bone. Really hurt. And it broke off under the skin, so we had to cut it open. It's not a big injury, but we had to cut it open, and it hurt because it's really, really deep, and it went all the way. It was like huge splinter, right? You know what's funny? It doesn't hurt right here. It hurts right here. It hurts right here. I feel it here, not here. Isn't that weird? That's weird. Very weird. I should probably see a doctor because there's something wrong up here. Yeah. Okay, Marlene, here's my question for you. If you're multiplying numbers, right, does it matter if you change the order of the numbers? No? Who do you think in here would be able to give us an example of how you could change the numbers, but the product is still the same? Okay. Yeah, why not? Let's live a little. You're picking Eileen, huh? Hi, Eileen. Can you give us an example of how you can change the numbers when you're multiplying?
Just flip it.
Mm-hmm. Like what?
Like the top number to the bottom number?
No, that's division. Can you think of an example of how you're multiplying two numbers and you can change them around and it doesn't change the answer?
Yes, sir, you do know.
Like what?
Like 5 times 3
So Jacobo says 5 times 3, which is 15,
and 3 times 9.
and that's the same as 3 times 5, which is 15. Do you see what we're talking about now, Eileen? When you're multiplying, you can change the order, and it doesn't change what the answer is, right? Okay. So when you're talking about 5 over 4 times 8 over 3, I want to explain why this shortcut works. Because it gets confusing because you're doing it across and it doesn't seems like it's a made up thing, right? So here's what's happening. What we're actually doing is we're changing the order. Because would you agree 5 times 8 is the same as 8 times 5? And I don't have to change the bottom one. You see what I did? And I can reduce this one. Because look, wow man, I'm getting kind of nervous. It's Tuesday. It's been a long day. It's been a long day. But I think 8 is equal to 4 times 2. Yeah? 8 is 4 times 2. And Ernesto, is 4 equal to 4 times 1? Okay. And that's 5 times 3 still. What's that number? 1. Juan. 2, 3. 1. And then 1 times 2 times 5 is 10, and 1 times 1 times 3 is 3. That's what really happens. But I don't think you want to write all of that step. I think it's easier just to do like this and just see it and recognize that's what happens. Ernesto, if you want to write all that, you go on ahead. You just rock on with your bad self. You can do the whole thing. Right, Gabby? You can too. You want to do that? You just go right on ahead. Here's what I would like you to do right now. Before I forget. Here's what I want you to do. I want you to write down, let's see, today, I want you to write down the date, okay? Because this is like a checkup. Ready? Checkup. Because we talked about something last Thursday, and we're going to check up on it. So today, would you agree? 1/30/2018, right? And last class we had was 125, right? That's 5 days. 24 hours a day. 5 times 24 is like 120 hours.
Do I have to write all that?
Mm-hmm. You have to fill in the blank. I'm not going to see the number. It's not that I don't care what the number is. It says I spent blank hours of the last 120 hours. Punctuation's good. Doing math so I can pass this class. Because what I'm going to do, I want you to be honest with yourself. If you lie to yourself, then you get trapped by the lie, and then you're going to be stuck. And by stuck means you can't improve. So Ernesto, here's what we're going to do. You're going to estimate how much time you spent since last class practicing math. And then after we take our quiz, 2 weeks, you're going to look at this number. We talked about spending 10 minutes a day, right? For 5 days. I would say that's an hour. That's really not very much, but that's a little bit every day. Some of you might have to scratch this out and put seconds. Okay. Marlene, the only reason I'm doing this is not like, there's one reason. And that is so that when you have a good grade, you can look and say, oh yeah, I was working consistently. If you have a bad grade, you can say, look, I did that to myself. I didn't put in the time I needed. Jackie, the time's going to pass, whether or not you get done what you need to get done.
Is there a put a name on it?
No, you're going to keep it.
Okay.
You're keeping it. It's you. This is yours, Jacobo.
Okay.
Do you understand? Like,
Yeah.
after this is going to be used to help you understand if you're doing yourself a favor, and if you're helping yourself, be prepared. Yep. It's kind of like, yeah, kind of like you're trying to lose weight, and I'm asking you how many milkshakes you ate. Milkshakes. Okay, Jackie. Did you write a number there, Jackie? Is it true? Okay, good. I have a question for Marlene again. Oh yeah. Marlene, which is better, cake or pie? Really?
Cake, I don't eat cake.
You don't eat cake?
Or
Or pie, really? Oh my gosh, I'm really good at eating both. I was just wondering. Like, I think pie is way better. But you don't have birthday pie. So, I was just confused. But I had another question. You know how you can change the order when you multiply? And the answer is the same? What about division? Does it work for division? Is 8 divided by 2 the same as 2 divided by 8? That's my question. Dang. Evelyn, what do you think? Does it matter?
It's just switched around, isn't it?
Yeah, so does it matter?
No.
So it's the same, like with multiplication? Because if this was times, this would be 16 and this would be 16, right?
Yeah.
Let's rewrite these as fractions to see. Like, to see if we can gain some insight into whether or not they're the same. If this was a fraction, which number goes on top? This one right here. Which goes on top, the 8 or the 2? The 8. And the 2 goes on the bottom. Remember? Okay, now let's think back. What's the 2 telling us? Yeah, you have a whole cut into 2 pieces, and the 8 says that you have 8 of that size of a piece. Right? So you have something that's cut in half, and you have 8 of those halves. What? Something's cut in half, and you have 8 of those halves. That seems impossible. How could you have that? Huh. You have 50 cents? Yeah? Can I have it?
Yeah.
Oh, wait, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of you. So if 8 of you gave me 50 cents each, 50 cents is a $50, right? If 8 of you gave me 50 cents each, which is a half of $1, how much money would I have? Oh.
$4?
I know, right? $4, right? $4.
Yes.
That would be 4 whole things. 8 halves is the same as 4. 2 goes into 8 4 times. Yeah? Right? Yeah. Okay. Getting on the right, yeah. No, yeah. See, right?
Wait, what did you say?
2 goes into 8 4 times.
Oh, yeah.
That's how you were taught division in elementary school. And it's wrong. Sorry. It's totally wrong. It's true, 2 goes into 8 4 times, but that's not really how division works. Here's how division works. 8 divided by 2 is 4 because, ready? Two times 4 equals 8. This number times that number equals that number. That's why it's true. That's how it works. That's like the official definition. You should probably write that down, Jackie. That's like, you didn't know that, right, Jackie? It's going to come into play in just a minute. I'll show you. 2 times 4 equals 8. That's why that's true. So Ernesto, well, I'll let you write it down. I'll shut up for a second. I'll give you another example that you don't have to write down unless you want to. Let's talk about 15 divided by 3. This is asking a question. This is saying 3 times K is 15. That's what that is asking. 3 times what is 15?
5.
5. This is 5 because 3 times 5 is 15. So this is the same thing as 5. 5 and this are the same. Does that make sense, Evelyn? It's pretty weird, right?
Yeah.
Okay, now let's take a look at this one. This one's saying 2 over 8. It's saying 8 times what number equals 2? How much of 8 is equal to 2? How many 8s? 2 is less than 8, right? So it can't be 4, can it? Because 8 times 4 is 32, not 2. So these aren't the same. So Evelyn, you can change the order when you multiply, but not when you divide. It's different. It's different because this one's the denominator and that one's the numerator. That's the denominator. So like what this is saying, 2 over 8, that's saying you have something that's cut up into 8 parts and you have 2 of them. Right. Your puppy got run over by the lawnmower and it's cut up into 8 parts and you can only find 2. Pretty sad. Poor puppy. Poor puppy. Okay. So I have a question for you. What do you think that equals? Because you're going to have 2 things that come up in this class later on that are going to get you into points of confusion, and it's going to be sad because you're going to have all this really cool math that you've done it all right, and you're going to get to this and you're going to miss it. So my question for you is, I want you to write this down. I want you to write down this is what this is asking. This asks, so you do it. Write down what this is asking. See if you can make sense of this to figure out what that question is asking. Well, and I'm going to see if I can get this to focus better. 3. Oh, look at that. That's beautiful. Clear. Claro. What's it asking? Do you know, Marlene? Maybe. Do you think Eileen knows? No? Wow, where's your faith in Eileen? Eileen, do you know?
No.
Really? Wait, you can't figure out what this is asking based on how this is?
How many times is 5 equals 0?
No, it's not asking that.
5 times y equals 0.
Dang, Jackie, that's why you're my favorite student.
Come on, mister.
I just told her that to make her feel good. You're my favorite student, Marlene. I just want Jackie to feel good, Right, Jackie? Jackie said, this says 5 times what? 5 times what is 0? That's what this is asking. So when you're trying to simplify something like this, you're answering this question. Hey Jackie, 5 times what is 0? What? 0? 5 times 0 is 0? Jacoba, how do you say big 0 in Spanish? Sorry, Jacoba, forgive me. I apologize. That was a bad joke, and I'm sorry. Sorry.
What? No, it's
Okay. Oh, wow. So, this is equal to 0, because 5 times 0 is 0, right? So can you say anything divided by... No. Let's say that right here. Here's the fact you got to know. Here's fact. 0 divided by any number except 0 is 0. Whoa. Me too. But we're here anyway. And at the end of the semester, when you're taking your final, if you're missing stuff that we learned on January 30th, do you think it would be okay? You just said, I'm tired. I was tired on that day.
I'm always tired.
Me too. And then we die. So Jacobo, 0 divided by any number except for 0 is 0.
Then what is 0 divided by 0?
Oh my gosh, that's nerds fight over that. Like seriously. It's funny. Like I'll show you right now. You're going to see why they fight over it in just a minute, okay? I'm glad you asked that question, Jackie. You're doing way better than last time. See, it's Alex's fault, huh? Yeah. Okay. So Jackie's question is, well then what is 0 divided by 0? So let's back up and I'm going to show you something right here. Check this out. Are you ready? Okay. So let's say we wanted to talk about, we just said, okay, so we know this is true. We've got this bit well established. That's 0 because 5 times 0 is 0. So this is 0 because 5 times 0 is 0. So that's a fact. Okay? And this could be any number except for 0. And it would still be equal to 0. Because anything times 0 equals 0. I know that's not how you learned how to do division in elementary school, but I'm sorry, your elementary school teacher was wrong. They were teaching you steps to get an answer, but they weren't teaching you what you were doing. Now watch. This one, it's asking 0 times what is 5?
5.
Well, 5 times 5 is 25. Oh, 0 times 5. 0 times 5 is 0. It can't be equal to 5. It's like this is impossible. 0 times 5 is not, it's 0. But no, that doesn't work. You see what I mean? So what could it be? 0 times what equals 5? Well, since everything times 0 is equal to 0, like everything, okay, everything, which we mean all numbers. That's not all hashtags, right? All numbers times 0 is 0. Like that's so true, you could get a tattoo of it. It's not changing. That is true. Right? That's true. So when it's asking 0 times what is 5, and over here we're saying everything times 0 is 0, nothing. There's nothing times 0 that equals 5. There's not a number. No number.
So what do we do? We just leave it blank?
Well, no, you want to leave it blank because then it looks like you skip it, right?
So you just put no number?
You can put no number. Or the word they always use in math, undefined. Evelyn, don't put underfined. Underfined makes me laugh because underfined means like you were given a penalty like a fine, but it was too small for what you deserved. That would be underfined. Undefined means no definition. AKA not a number. Yeah? What's your question, Eileen?
What?
Oh, Eileen. What's your question, Eileen? Okay. Gabby's got a question? No? You sure? So, Marlene, are you distracting Eileen?
No.
You sure? I have a question for you guys.
Oh, Mr.
What about that? Isn't something divided by itself 1?
No.
Really? 5 divided by 5? 27 divided by 27? 42 divided by 42? Something divided by itself is 1, right? So, okay, so that could be 1. Okay. Isn't 0 divided by a number equal to 0? But also, isn't a number divided by 0 undefined?
Yeah.
So which is right? Oh, crap. This one's right? 0 times 0 is 0? So how could you take something and cut it up into 0 parts? it's generally agreed, Jackie, I like this better, but it's generally agreed that that's right. Now, undefined, you can't divide by 0. Okay. Jacobo, how are we doing?
Good.
Al 100.
Yes.
All right. Let's see if you guys can reduce some fractions. You ready? Ready? We're just going to do a couple problems. I want to see how we're doing. I'm going to put a few right here, and I want you to try them. And then we're going to do the new stuff for the day. So. Whatever you're talking about must be super important, right? Super important. So important that you're going to talk about that instead of learning math, right? Dang. Check this out, Jacobo. Simplify. Do you know what it means?
To almost like reduce.
Yeah. Reduce. It basically means do some math, whatever you see. Okay, so whatever you see that you can do, that's what you do. So let's say we had 5 divided by, oh, that's not very nice. And then one more. There, we'll do those 4. Do those 4. Let's see, I'm going to turn on the timer. How long do you think we need, Jacobo? 10 minutes for 4 problems? Okay, 10 minutes. We'll do that. Okay, 10 minutes. 10-minute timer. Okay, let's go.
Yes, good. Good, Rich.
Now it suggests when you're done, I would try them all on your own. Don't skip any. Even if you're not sure, try it. And then help each other out, and then we'll go over them, and then we'll be golden. I know, tell her. Don't use a calculator. You won't be able to use a calculator on a test. Don't even use it.
Oh shit, that's true. No, but we can talk about the hours around. Look. Nothing, so it's 0 on the back. Is that 3 piece or 8 piece? Let's see.
So if you use the calculator to help you check your answer, that's fine. But if you use it to help you get your answer, it won't help. How long have you known me, Jackie? How many classes have you taken with me? This being the third?
Yeah.
Oh, okay. Mm-hmm. Do you not trust what I say about how to learn math?
I do.
But it's always the hard way, huh?
Yeah.
Yeah. You know why?
Why?
Because that's what works.
The hard way?
Yep. It's what works. You know they used to do this class online, right? Like used to be a computer class, this class.
Uh-huh.
Yeah.
It was already.
Uh-huh. It was just a computer class only. Like even if you took it like in person with me, you would just sit in a computer lab and do it on a computer. Did you know
Like
that?
the ones in high school where you.
Mm-hmm. It was just like that. You know why they did that? Well, because everybody fails this class. Math 81 is the lowest level of math and it has the highest grade. So they figured there's got to be something wrong with instruction. So we'll just put it on a computer so everything is there like super clean and easy. No confusion. You know what happened? The failure rate went higher.
Really?
Yep. Because it's not the instruction. Even if it's a bad teacher, it's not the instruction. It's student habits. People want to do the easy way and that doesn't help them learn. True story, Jackie. So yeah, Coach E stopped doing those classes because of that reason.
I took a extra math senior year. That's pretty easy.
Mm-hmm. And you don't learn math, you just learn how to answer the questions so you get them right. But you're not learning math, you're learning the computer. That's the problem. Yep.
I remember what math was. It was an extra one.
Yeah. See, that's funny, you don't even remember the class.
Yeah.
I know, that was weird.
Isn't
Isn't that weird? Yeah.
Because I had an early schedule, so I could take extra classes, so I did.
Yeah. I didn't want an extra schedule, an early schedule in high school.
Well, I already had.
Because I was a turd.
I already had an early schedule, but it was too late.
Yeah.
I was an 8 for 2 classes.
I didn't want to be an 8 either.
You didn't?
It's not fun. It's work.
Depending on the teachers that you get.
That's true. I just wanted to cause problems.
I have issues.
Oh, yeah. All right. Ernesto, you ready? Oh, we're not. I told you guys 10 minutes, so let's see here. How many of you guys need more time? Yeah? Which one are you working on? 3? Okay. Go on. Go ahead. If you're done, maybe check with somebody. See if you got what they got. Don't be shy. Hmm. Ernesto, you're done with all of them? Yeah? What'd you get for number 1? I don't know. I'm just seeing what you got. Oh, yeah.
I got.
Yeah? Daniela, what'd you get? Same? What'd you get? Number 1.
I don't know. I got maybe a 4, but I don't know why I did it.
That sounds like math and magic. -4. Okay. What'd you get, Yolanda? Oh. Whew. All right, time's up. That's the timer. Yeah, that's just the timer. Okay. Let's go over these. Let's see here. You have to subtract first before you divide, because this is division, right? But you have to subtract first. Because you remember that thing, right, PEMDAS? We talked about it a little bit last time, right? That's in a group. It's in a group. And so you actually have to do that before you divide. So what I said was right, but it was also wrong, and that's very confusing. I said you have to subtract before you divide, which in this case is true because this is in a group. The fraction makes it a group. We say P stands for parentheses, but it means anything in a group, which could be a fraction, it could be a square root, it could be parentheses or brackets or all kinds of stuff. Anything in a group you have to do first. And then you do the rest. Exponents, multiply, divide, add, subtract. So here, that's 5 over 0, and that is undefined. Just like you guys said. Okay. Uh-oh. Oh my gosh. When I look at this one right here, I see a number, because that's a number, right? Divided by itself. So it has to be 1. A number divided by itself has to be 1. Right? When you think about it that way, right? A number divided by itself has to be 1. Unless it's 0 divided by 0, and then nerds are going to fight. So, Marlene, I think this has to be 1. Now the way we divide is we multiply by the reciprocal, so I'm going to multiply, flip it over. Oh, now let's reduce before we multiply. See, 5 goes into 5 one time. 3 goes into 3 one time. 1 times 1 is 1. 1 divided by 1 is 1. It's 1. Now, Yolanda, you said duh afterwards, right?
Mm-hmm.
But you probably didn't read it, huh? You probably did the work.
Exactly.
But if you just like read and see what it says, then it's a lot easier. And that's one of the things, like, if there's one thing that I could really teach you guys to do that stays with you, it's that you learn how to read things in math to make sense of them. Because that's going to happen for you outside of class. Like, in everyday life, you're going to see things in math, and if you can make sense of it, then you understand, and it's easy. And then you don't get ripped off. Because that's what people do. They hide things in math to rip you off. That's called fine print. There's like numbers and percentages and stuff. And yeah, they're stealing from you. Okay, this is different. This is 9 over 25. Yeah? Okay. We need a common denominator. So we have to find the LCM of 8 and 4. And that's 8, right? So I need to make this into an 8. And the way I do that is by multiplying by 2 over 2. So this one stays the same. This one is 6 over 8. Something minus itself is 0, right? Something minus itself has to be 0. But the way we do fractions, right? The denominator, when you add or subtract, the denominator does not change when you add or subtract. So that's still 8. But look at this. 6 minus 6 is 0. And this, Ernesto, is saying 8 times what? 8 times what number equals 0? That has to be 0. 8 times 0 is 0. You thought I was just being all crazy giving you guys numbers like this. But yeah, there's a reason. And it's going to come up again later. Evelyn, how was Starbucks the other day?
Pretty full.
Was pretty full. I was going there to get the old coffee grounds.
Which one?
Like after they make coffee and espresso and whatever, they put them in a bag and they give them away. Because you can put them in compost or your garden, and your garden likes it. Yeah.
What were you doing in that, like, jacket thing?
I was probably doing yard work. Oh, Saturday, huh?
Yeah.
Oh yeah, I was fishing, and I had just was coming home, and we left in the morning. It was really cold. Yeah, it was like 24 degrees when we left my house. Yeah, but we caught 6 fish. Trout are good, and then I cut them up so there's no bones. I learned how to do that, and so then we mix them with pico de gallo and avocado.
That sounds really good.
It is really good. Marlene, I know how to cook. My wife, we don't mess around in my house, Marlene. We cook. And then we eat.
And I've seen pictures on your Facebook.
I know, stalker.
Yes.
Yeah. Yeah. All right.
Yes.
Yes. Oh,
I thought you had to do it to the both
this one?
the least, yeah.
Number 3. Well, you have to do top and bottom the same, right? But what you really need is you need these numbers to be the same. And so you can do something different to this side. as long as you do the same thing to the top and the bottom. Like, let me washa. Watch, check it out. I'm glad you asked, Marlene. Check this out. Like that one right there. My common denominator has to be 15. That's the smallest thing that 5 and 3 go into, right? So what I'm going to do to make this into a 15, I wish I could just put a 1 in front of it and then a 1. That doesn't work though, right? People do that all the time. Don't do that. I have to do it with multiplication. So I have to multiply by 3 over 3. And Evelyn, 3 divided by 3 is 1, right? And 1 times something doesn't change what it is. Just looks different. So this is going to be 3 over 15. This one I'm going to multiply by 5 over 5. And the reason I'm doing both, Marlene, is because they both have to change to be the lowest common multiple. Whereas here, I can make 4 into 8. So I didn't have to do anything to the 8. Does that make sense or no? Kinda? Maybe. Probably got to practice a little more. I see. Yeah. You need these numbers to be the same. That's what you need. How you get it can be different. But what you do to the denominator, you have to do the same thing to the numerator. Because that just equals 1. So this would be 8 over 15. Mm-mm.
Like the number 4 and what I did.
Yeah.
This was the most from last time we said we had to find the least common denominator.
Mm-hmm. Yeah.
And then
Lowest common
notes,
denominator.
the first one I did 8 and then
But 4 goes into 8, right?
yeah.
That's what you check first.
Okay.
Did you do 16?
Yeah.
Okay, so watch. Dang, Marlene. You know, I'm glad you're asking this question, and the reason why is a lot of times everybody learns a bunch of extra stuff when a student asks a question, because there's always other things that come out. Like what might actually confuse you, you might not even know you're confused about it until we start talking. So washa again. Ready? Knee down. So it's easier if you find the lowest common multiple, which is 8. But let's say we're going to make it 16 instead. So let's say we're going to make that 2 over 2, which is 12 over 16, right? And this one by 4 over 4, which is 12 over. You still get the same answer because 12 minus 12 is 0, and the 16 stays the same, and that equals 0. So same thing either way. But if it didn't equal 0, then you would end up having to reduce. And so you'd have another step because you found a denominator that would be too big. Do you want me to show you what I mean?
Yeah.
Do you have $10? Okay, I can't. Okay, here's what I mean. Let's say, Ernesto, let's say we were going to do 3/8, and then let's say we were going to subtract 1/4. Okay? Let's do it the easy way first. Way. Have one. See? Way. Oh yeah. We're going to do the easy way first. And then we're going to do the difficult way. Okay? And this one's going to be easier because we're going to find the LCM. Lowest common multiple of the denominators. And that's going to be 8. And this one's already 8. So that's going to be 3. And this one's going to be 2. I put them on the same thing. But you don't have to put them on the same thing. If you wanted to write it like this, 3 over 8 minus 2 over 8, these are the same. It doesn't matter. I like this way better. Ernesto, which way do you prefer? This way? Or that way? This way? Yeah, that's the way you're taught originally. But either way, that's 1 over 8, and so is this, you see? Same answer. Okay, now, let's say we got a denominator that wasn't the smallest one. So let's say not the LCM. Okay, so let's say it's going to be 16. So we're going to multiply by 2 over 2. That's 6 over 16. And this one's by 4 over 4. So that's minus 4 over 16. That's 2 over 16. I'm going to write that and make it neater. That's not reduced. Because you can divide by 2. To reduce that one, you have to divide the top and the bottom by 2, and you get 1 over 8. So more steps. If you find the LCM, you have less steps. And you don't have to do the thing that is maybe the most confusing, and that's reducing. Yeah. Marlene, that's why you're my favorite student. Okay. You ready?
Yeah.
You sure? You know what we're doing next?
No?
Square roots
Oh, the square roots.
in the house. Yeah, we're gonna do square roots. It's gonna be awesome. Gabby's excited. She's like, I've been waiting for square roots. Finally. She's like, I was praying to sweet baby Jesus that we'd do square roots. Okay. There it is. Square roots. Dang, Jackie. Jackie,
Yes.
what's a root? Like this word here, root. What's a root? You ever pull a hair out and it hurts?
Yeah.
You see that little thing at the bottom? Looks like a viejo, but it's not. Yeah, that's your root. That's where it grows. That's where it starts. Your hair starts at your roots. Right? So a root is the beginning of something. It's where something starts. So it's the beginning or where something starts. It's where something comes from. Where you were raised, where you grew up, that's what they call your roots. Your roots are where you're from. So Ernesto, I guess your roots are under the bridge. Just joking. Sorry. Just a little joke, Ernesto. I'm sorry. Will you forgive me? Oh, good. All right. So yeah, your roots are where you're from. So if you're from Nogales, Arizona, that's your roots. So a square root is where squares are from. A square root is where squares are from. A square root is where squares start. I guess that doesn't make any sense, does it? What do squares start with? A line, a side. For example, watch. Let's say this was 5 feet from there to there. That's a line, right? If I were going to make a square from that side, then I would just make another 5 feet. And I'd make another 5 feet. And I'd make another 5 feet. And I would put them all together in 90 degrees. That's what those are. So that it makes a square. All sides are the same, right? Squares start from the side. So, dang, Jacobo. Glad you're here, Jacobo. You're gonna set your sister straight on this. Watch. She had your back on the fractions, but you're gonna take her to school on this. Watch. Because you remember some of this, right?
Yeah.
Yeah. See, watch. I'm telling you, it's fancy. So, fact: squares start. Whoa, hi. With the length of one side. How you doing?
Good, how are you?
Fantastic. Daylight savings.
I had to work.
You should. I'm working with you here. Daylight savings.
Yeah.
Yeah, you're traveling from back east.
Yeah.
Yeah, the clocks get messed up. I know. Yeah, that's right. Where do you work?
I work at Safeway.
Oh, what do you do there?
I work at Safeway.
Love Safeway. Continental or Duval?
Duval.
So not as old as the other. Like the people, they're still old.
All of them are.
But Continental's like I wonder how many people die in there every day. Like the customers, they're old.
Well, all
Yeah.
you see is gray hair all day.
Oh yeah. And I like when they drive through the front of the store. On Continental, they do that. Well, they used to.
Yeah, I heard that.
Yeah, it was funny. And then the lady sued Continental, the Safeway on Continental, because they shouldn't have parking spots in the front because someone might miss it and drive into the store. Like the whole car into the store. Because that's what happened, Jackie.
Really? How long ago?
Maybe 4 or 5 years. Yep. Happens a lot, though. Not to just that sort of stuff. So, all right. So here's what we got. A square root is talking about where a square starts, and squares start with the side. Okay. Now, when we're talking about a square, what we're really talking about is the area of a square. That's what we're really talking about. The area of a square. They're going to give you a number that's going to be the area of a square. Oscar, do you know how you find the area of a square?
You multiply the base or something.
That's right. It's going to be the side, right? It's going to be the side. A stands for area, right? Oh, sorry. A stands for area, right? A stands for area. Area is the side times itself. Or, another way to say that is area is side squared. We're learning all kind of fancy stuff here. So that all makes sense so far? Nothing groundbreaking so far, right? Like I got all that, right? So what's the area of that square? What is it? Tell us. 25. Right, thank you. 25. Would you guys agree with that? 25? Okay. So here's what square roots do. Square roots, you know the area. They're asking you how long is the side. So here's what square roots are doing. Square roots are asking about the side of a square. Literally, square roots are asking, square roots give you, okay, can you guys read my handwriting there? Is it a little small? Yeah? Okay. Square roots give you the area. Is that better? Okay, so square roots give you the area and ask for the side length. That's what they do. Square roots are just a way of writing a number. It's a way of asking a question. So when they give you a square root, they're saying, hey, I got this square, and this is how much area it has. How long is the side? That's all it is. So, for example, let's talk about, well, do you guys know what a perfect square is? Perfect square would be like 1, 4, 9, 16, 25, 36. These are all numbers times themselves. So like this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Like 100 is a perfect square because that's 10 times 10. Yeah? Okay. So these could all be areas of easy squares. So like for example, that's 3. The square root of 9 is 3. We could, let's see here. Let's see, maybe, because you guys, nobody believes people. Oh, not calendar, shut up, calendar. Calculator, let's see here. 9 square root. Oh my gosh, square root of 9 is 3. It's got to be true. So that's 3. But here's why. Here's why this is 3. This is asking a question. This asks, what squared? What times itself, right? What's squared? What times itself is 9. So one number times itself that equals 9. 3. That's what they ask. Jacobo's like, I got this. In the bank. Yeah. Eileen, you doing okay with that? Yeah? So if I asked you for the square root of any of these perfect squares, it should be pretty easy. You just say, oh, well, I just got to figure out what number times itself equals that number on the inside. Okay, bonus question. Whoever gets this right, Jackie's going to give $10 to. Got 2 questions, so we'll have Jeopardy and double Jeopardy. However, she's going to give you $10 for every right question, but every wrong question, you have to give her 5. You want to play, Jackie? Do you think you'd win? Okay, first question. What's this symbol right here called? What's it? Do anybody know? Like, we say square root, but it actually has a name. That little house thing right here. This has got a name. Second question is, what's the number on the inside called? Anybody know? The number on the inside is called a Radicand. The number on the inside is called the Radicand. And the square root symbol, it's called the, I'll move my hand so you can see. It's called the radical symbol. That's all. I don't know if we'll see why they're called radicals in this class or not, but yeah. Daniela, did you know that? You didn't know that? Uh-oh. So you're learning stuff today? I'm sorry. All right. Okay, Yolanda, you ready? So I want to give you guys something you can reference. So when we're learning how to simplify square roots, you can use this to help make sense. So it'll be a little easier. All ready, Evelyn? So what we're going to do is we're going to write down a whole bunch of perfect squares. So we have a few here. We're going to write a bunch of them. So if you're at the bottom of your page, then you might want to turn the page, and that way you can find it. Okay? You ready? Okay. Perfect squares. Just like all of you, perfect. Perfect squares. Okay, here they are. 1 is 1 squared, right? Oh boy, let's see, what comes after 1? Oh, 2. 2 squared is 4. I'm not very good at this number thing. 3 squared is 9. You good? And then 16, 25, 36, 49. Right? Because that would be 4, 5, 6, 7, and then 64. 81. You probably already knew all of this so far. 121 and 144. You probably knew all those first 12. Because usually in elementary school you do multiplication up to 12. So 12 times 12, 144. That's 12 squared, 11 squared, 10 squared, 9, 8. Well, I was going to say 7 and write 2, but I wrote 7. I wrote 8. Yeah. Anyway, 7 squared, 6 squared, 5 squared, and 4 squared. Okay. Next, 13 squared is 169. 14 squared. Check this out. Turn it around. You see? They just switched the 2 numbers. That's yeah. And then 15 squared is 225. And then 16 squared. Do you remember? I think it's 256. I think it's 256. 256. I think it's 256. And then I think it's 289. No. Oh, 289. And then 324, and 361, and then 400. Jackie, do you trust me that all these are right? I don't. You know which one I'm not sure about?
17.
Yeah. But you know what makes me pretty sure I'm right? 7 times 7 ends in 9. 7 times 7 is 49, and that ended in 9, and that'd be 7 times 7. I think it's right. Should we check?
Yeah.
Okay. 17 times 17. Wow. 289. The only reason I know all those, Jackie, is because I've been teaching this stuff for a long time. You just remember after a while. Just like how, well, actually not anymore. People don't know phone numbers anymore. But you know all the extensions that work, right? Is it because you sat down and studied them?
No.
Or just because you use them all the time?
Right.
That's how I know this.
Uh-huh.
I just use them a lot. So, if you were asked, like, a square root, if the radicand was any of these numbers, it should be really, really easy. Because all you got to figure out, like, for example, let's use our favorite one today, 289. 289 is asking what number times itself equals 289. That's what that is asking. That's 17. This says there's a square, and the area of the square is 289. How long is the side? That's what this is asking. Right here. That's what that means. So it's 17. Yes, Gabby? No, Gabby? Yeah, Gabby? Okay, Gabby. How's Ross?
Cool.
Especially the one down here. Yeah, it's crazy. Yeah. Okay. All right. Evelyn, are you confident that if I gave you like one of these numbers in a square root, you could answer it? Are you confident in that? So like, let's say I picked one of these numbers. Could you figure out what that equaled?
I won.
1. Because 1 times 1 is equal to 1.
Yeah.
Okay. So, Jacobo. Oh, I thought he was right there. Did he run away? Was he in the door and then he heard me cut it? No, it wasn't him. Dang. I was going to put him on the spot. Here's my question. This equals 5. Why? Why does this equal 5? Because if you can answer this, then you understand. And then what's going to come next, which looks more complicated, will be easy. So you have to be able to answer this. Why does that equal 25? Or, sorry, why does that equal 5? Because 5 times 5 is 25, and this is asking what times itself is 25. The answer to that question is 5. This is asking a question, that's all. You have to read it like a question. What times itself is 25? Square roots are looking for perfect squares. They're sad. Square roots are sad. They're looking for perfect squares. Square roots are just numbers. Just numbers like all the other numbers, but they're misunderstood. And it makes them very sad. They just want to know where they fit. They want to know what made them. They want to know who their parents are. They are homeless McKinney-Vento children.
Oh, no.
That's what they are. They are. They just want to know where did they come from. I know who I am, but I don't know where I came from, and so they're very confused. That's what they're asking is, who are my parents? Who were my parents? 5 was its parents. You see, Ernesto? This one right here, for example. This one's 100. Kind of a big kid. Wants to know, who are my parents? Who are my parents? This one, for example, is a little kid. 4. Who are my parents? 2. Its parents were 2. This parents were 10. That's all. Do you see, Jackie? They're asking a question. Square roots are asking a question. Square roots are asking a question. That's it. What's the matter, Ernesto? What?
I'm sorry, it's just, you always pick on her, it's funny. I'm sorry.
I can't help it. If you knew Jackie, you would pick on her too. You know why I pick on her? You got to get out ahead of Jackie, because otherwise she's like just a train, and she'll just run you over. She looks like all nice and sweet, but she's morally corrupt on the inside, and she'll just hurt your feelings. Is that true, Jackie? No, it's not true. I just know her for a long time. And there's not very many people, and I don't know most of you very well. Not well enough to pick on you yet. But I'll switch to you, Ernesto, don't worry. You're good?
Thanks, being the one.
All right. Okay, so now we're almost done, okay? Just give me a couple more minutes, and then we're going to be done for the day. So you guys know how to do the square root of a perfect square. What about something like this? Oh, boy. Oh, man, we were all getting along. It was so nice. You want to check, is that Radicand, the 50, is it on your list of perfect squares? Because it wants to know who its parents are. And this is the list of parents right here. I don't see 50 on the list. You see, I don't see 50 on the list. Jackie, you have parents, right? Mm-hmm. That's cute. Yeah. Ernesto, you have parents? What's that? Yeah, okay. So Ernesto, this kid right here, 50, doesn't have parents. Well, doesn't know who they are. It wants to know who are its parents, and its parents are perfect squares. So what it's doing is it's looking for a perfect square. I'm trying to think of how to say this. What do rabbits do? They say they breed, they multiply, right? That's what they say. Rabbits multiply. That means like their population grows like crazy because they breed, they multiply. Right. Two things that are multiplied together are called factors. Right? Right? So if you have a baby rabbit, its factors would be the mom and the dad. The mom and dad multiplied to make the baby. Right. Some pair of numbers multiplied to make this baby. We are looking for a perfect square that is a factor of that. Do you see? So what we have to do is we actually have to factor 50. That's what we're doing right here. So make sure you understand what we're looking for first, and I'll tell you how to do it. We are looking for, because that's not a perfect square, so we're looking for the biggest factor of 50 that is a perfect square. That's what we're going to look for. So what we're going to do, factor 50 to find the biggest. And that's, I put it in capitals because that's the thing everybody's going to mess up. You're going to find a perfect square, not the biggest perfect square. Find the biggest perfect square. Did Jacobo go on vacation? I don't know either. Kind of crazy. Okay. So, Oscar, here's what we're going to do. Until you get really good at it, I would do this. On the side, I would say, okay, 50. Let's say that's 1 and 50, 2 and 25, 3 doesn't go in. 4, no, 5, yeah, 5 goes in 10. 6 and 7 and 8 and 9 don't go in. The next number that goes in is 10. And do you see how it turned around? That means you found them all. So when you're making your list of all the factors, when they turn around, you found them all. As long as you check in order. Don't skip around. Marlene, the moment anybody, myself included, starts skipping around with the factors, the one I skip is the answer. Like, guaranteed. It's just Murphy's Law. It's just Murphy's Law. Yep. The one you skip is going to be the answer. So don't skip. Go in order. Okay? Now, what is it we're looking for? The biggest perfect square. So 1 is a perfect square, but not the one we need. That's a perfect square, right? That's the one we need. So here's what we're going to say. We're going to say that the square root of 50 is equal to the square root of 25 times the square root of 2. Because that's true. The square root of 50 is the square root of 25 times the square root of 2. That's true. You can break apart square roots like that. They're still both square roots. Word to the wise, ready? This is a pro tip. Write the perfect square first, then the other one second. Because when you write your final answer, it'll make it a lot easier. So it's not wrong if you do this. Whoa. It's not wrong, but you might mess it up. You might get yourself confused. Okay. Eileen, you ready? This is exciting, Eileen. I'm glad you're seated because you might just you might fall right over. Because check this out. This right here is a number. And it's being multiplied by another number right there. You see they're multiplying. That's a cow's favorite kind of math. Right? And this number is 5. Isn't that 5? This is asking what times itself is 25. That's 5. That's 5. But what number times itself is 2? But 1 times 1 is 1. 2 times 2 is 4. There isn't a number times itself that's 2. You're done. So square root of 2 cannot be simplified because it doesn't have a factor that's prime. Or, sorry, I was thinking one thing that I was writing another. It doesn't have a factor. It doesn't have a factor. That's a perfect square. Is SQ okay for square? Now some of you guys might know that 2 is prime, which means it has 2 factors, 1 in itself. We haven't talked about that yet, but that's also how you can tell. So Evelyn, we need to just go ahead and write our answer like that. And now we're done. That's it. Here's what we're saying. We are saying, when we write this right here, when we write the square root of 50 equals 5 times the square root of 2, here's what we're saying. We are saying, this is the question, what number times itself equals 50? That's what that says. We're saying that the number times itself that equals 50 is 5 times the square root of 2. We're saying 5 times the square root of 2 times itself is 50. Seems obvious, right? For sure, right? You do 5 times the square root of 2 all the time, right? 5 times the square root of $2? Well, never, huh? Should we use it? Should we use our fancy calculator and see if it's true? Okay, here's our calculator. 5 times the square root of 2. Oh, it didn't do. Oh, I got the order of. Okay, square root of 2. Oh, I don't know how to use this calculator. 5 times. Oh no, I did the square root of 5. Hi. We'll do it this way. We'll do it this way. Hold on. Let me get my calculator on my phone. Can you guys see? Oh, you guys see my old phone? Okay, 5 times the square root of 2. Ready? I'm going to multiply that times itself because that should be equal 50, right? Because let's make sure. We're saying the number times itself that equals 50 is 5 times the square root of 2. So that means this number times itself should equal 50. So I got 5 times the square root of 2 times 5 times the square root of 2. And it should equal 50. And if it doesn't equal 50, I quit.
Got yourself a job.
Dang it! I was looking forward to McDonald's. The number times itself that equals 50 is 5 times square root of 2. Alright. Almost done, I promise. Just 2 minutes. 2 minutes, I promise. 2 minutes. Daniela, the way you do these is you factor the radicand, look for the biggest perfect square. So let's try one. You ready? Let's try one. Let's do the square root of 48. 48. Okay, I want you to try it. Factor it and look for the biggest perfect square. And then I'll help you out from there. Almost done. Factor it and look for the biggest perfect square. I guess she doesn't like square roots. Sad story.
If you can use my phone calculator.
What?
It's because
For the division?
for the multiplying part.
148. Does 2 go in?
Yeah.
24?
Uh-huh.
How about 3?
No.
There's a shortcut for 3. Want me to show you?
Yeah.
I want to see if 3 goes into 48, right? The shortcut is I can add these two numbers. And if that number is divisible by 3, then so is 48. So 48, 4 plus 8 is 12. 3 goes into 12. So 3 goes into 48.
Wait. How is it again?
4 plus 8, 12.
Oh, okay.
Now 12, look at 12. 1 plus 2, 3. 3 goes into it. That only works for 3s. But it works. So 3 goes in. Now I got to figure out how many times. Let's see, 48. Dang it, I got to take off my shoes. 1, and carry that, so 1 carry 8. Oh, 16. Oh, 16, okay. Let's see. 5, 6 goes in 8 times. 7 doesn't go in, but 8 goes in 6 times. You see? Done. Now, are you guys having trouble putting it together? Because look, this is our biggest perfect square, right? Oh, I skipped 4.
Yeah, 12.
4 and 12. But I skipped 4 on purpose. Well, not on purpose, but I skipped it because I knew 16 was the biggest. 16 is bigger than 4. And you want the biggest perfect square, 16. Here's what we're going to do. We're going to write this as 16, the square root of 16, times the square root of 3. Now, nothing goes into 3 that's a perfect square. Nothing. That means that the square root of 3 can't be simplified, so that's going to stay the same. But this number is asking what times itself is 16. And I think you guys all know that's 4. So that's your answer. So Marlene, I think practicing a few of these between now and Thursday would be a really good idea. Because you kind of got it. A little bit. You kind of got an idea. Yes, Jacobo?
Where did you get the square root of 3?
Because 3 times 16 is 48.
Oh, okay.
Yeah, you see how you break it apart. You find the biggest perfect square, and then you break it apart. You factor it.
Right.
Yeah. And then you simplify the perfect square. And then the thing that's left over is just the square root that's left over. It's called irrational. We'll learn about that Thursday. So I'm only going to give you just a handful of problems. And they might take you 2 or 3 minutes, and you might get frustrated. Because a lot of time in math, you've kind of been exposed to the idea that if it takes more than like 15 to 20 seconds, you're wrong. That's like an impression that a lot of people have about math, especially people that struggle with math. Because after like a short amount of time, then they just start doubting themselves instead of figuring out what to do. So these might take a while because it's brand new. So here's what we're going to do. I'll write them on here for you, okay? But it's in your book. If you wanted to know, it's in your book. It's page 54, and we're going to do numbers 17 through 21. And I'll write them right here for you, okay? So what you're going to do is you're going to simplify. Let's see, square root of 20, square root of 50. We already did that one. But don't cheat. You can use your notes to help see if you did it right or help get yourself unstuck. Square root of 12, and the last one, oh man, 250. Yep. So that's what we got, ladies and gentlemen. Try them. Get stuck. Try them again. Get stuck. There's lots and lots of videos on how to do these that can be really helpful. And if you want to know some in particular, you can email me and I can send you in the right direction. Okay? But try them and then show up on Thursday with questions. That's all we got.